I'm just creating this video because since half of the class was testing, I want to make sure that you have the right answer on the homework assignment. Okay, so go over this video. Remember that you have it on Friday. Go over this video and make sure that you're understanding this topic before that test. And I'm going to start with number 3 because number 1 and number 2, they were solved in the first video that I was posting on the assignment. So here I'm going to start with number 3. And as you can see over here in number 3, you are asked just to decide between fluorine and iodine, which one of these two elements they have a higher ionization energy. Higher ionization energy. The first step that you're going to complete is, see, you're going to analyze that trend, okay, in a group, because fluorine, F, and iodine, I, both of them, they are halogens because they are located on the same group, okay? So you're going to look at the periodic table. Fluorine is the first one. Iodine is in period 1, 2, 3, 4, in period 4. This one is in period 2. This one, okay, iodine is in period 4, okay, period 4. So you're going down a group. Ionization energy. What is ionization energy? The energy that is needed to remove the last electron. Remember, the electrons or the valence electron, because the valence electrons are the ones that are located in the last level of energy. What's going to happen down the group is going to increase. Why is going to increase? Because remember that when you're going down a group, you are increasing the level of energy. So the nucleus has no control over the last electrons or the electrons located on the last level of energy. Fluorine has a small atomic radius. So the nucleus of fluorine has full control over the electron on the last level of energy. Knowing that, what is the answer for that question? See? Okay. Simple. Okay. Fluorine has the highest ionization energy because first it has the smallest, okay, atomic radius. Atomic radius, meaning that it has a full control over the electrons in the last level, okay, of energy. Y I'm going to continue over here on the corner. Consequently, comma, is going to be more difficult to remove those electrons. So you're gonna need more energy to remove the electrons that fluorine has on the last level of energy, that iodine, because iodine has like 4 levels of energy. It's in period number 4. It's in period number 5. Period number 5. My mistake. This one, fluorine, is in period number 2, and is 2, 3, 4, 5. Iodine is in period number 5. 5 level of energy. Iodine doesn't have as much control of fluorine over the electron on the last level of energy, so it's going to be more difficult to remove them. So you need more energy in this case, in the case of fluorine, than in the case of iodine. Now, question number 4. Because remember that 1 and 2, they were solved in the video that I was posting before. Why do elements in the same family generally have similar properties? Family means the same group. If you don't know this, or you know this, or you don't remember, the elements that are located in the same group, they have the same amount of valence electrons. Miramos igual a valence electrons. Valence electrons are the electrons that are located in the last level of energy. Okay, so if you are in group 1, Group 1, alkali metals, group 1. All of them, they have one electron in the last level of energy. And that's why all of them, from lithium all the way through francium, they have the same or similar chemical properties. Let's say that we're talking about group, okay, 15. Nitrogen family, nitrogen all the way through the last one that you have in that group, they have 5 electrons in the last level of energy. If they belong to the same family, because all of them, they're going to have the same amount of valence electron on the last level of energy, meaning that they have similar chemical properties. Number 5 is super simple because you have to analyze whether the following property increase or decrease from left to right across the periodic table. When they're talking about left to right, they're talking about a period. When you're moving from the metal part all the way through the non-metal part, okay? Atomic radius, you know that the atomic radius, okay, is the distance from the center of the nucleus all the way through the last level of energy. And even though the atomic number is going to increase in a period, the nucleus is gonna like become bigger faster. So the atomic radius in a period is gonna decrease. Okay? First, ionization energy. We are gonna assume that you're talking about ionization energy. And I was talking about that. Ionization energy is the energy that is needed to remove electrons that are located in the last level of energy. Okay, so when you're going from left all the way to right, the atomic radius is decreasing, meaning that the non-metals, they have more control of the electrons on the last level of energy. So in a period, ionization energy is going to decrease as well. Okay, and electronegativity is the ability to steal electrons. I don't know if you will pay attention to my video, but I was explaining in my first video that electronegativity is the ability. No, I was explaining that the tendency of the metals is to lose electrons, while the tendency of the non-metal is to accept them. When you are moving from left to right, you're moving from metals to non-metals. Metals, do they accept electrons? Answer is no. See, so in a period, when you go from metals all the way through the non-metal part, electronegativity is going to increase. And why? Because electronegativity ability to steal electrons. And metals, they are not stealing any electrons. Okay, number 6. They say, what trends in atomic radius occurs down a group on the periodic table? Oh my goodness, easy. What caused this trend? So easy. As you're going down a group, see, period 1, period 2, period 3, period 4, that numbered is the principal quantum number. It means, okay, or it's giving you information about the main level of energy. Okay, so elements that are located in period 1, they have only one level of energy. Period 2, 2 level of energy. Period 3, 3 level of energy. Meaning that the level of energy are increasing as you go down a group. So the distance from the center of the nucleus all the way through the outer, part of the atom or the boundary of the atom is gonna increase. So the atomic radius down a group, atomic radius in a group will increase. Why will increase? Because an increase in the level of energy. Level of energy. Okay? So 7, number 7 here. De nuevo, dice, what trend in ionization energy occurs across the period in the periodic table? I'm not going to explain that one because I gave you the explanation. Ionization energy across the period, you know that it's going to increase. You know why? Because I was explaining that before. Over here is a circle the atom in each pair that has the largest atomic radius. And when you're solving problem like this, that by the way, you're going to have that on the test, you have to look at the periodic table. Ms. Ramos, are you going to give us a periodic table for the test? I'm going to give you the book. So you have a periodic table at the end. So aluminum is in group 13. That's aluminum. But boron is in group 13 as well. Both of them are in the same group. Same group. So aluminum is in period 1, 2, 3. Period 3. Boron is in period 2. And this is so simple because you see, analyzing atomic radius, and you're going down a group, it's going to increase or decrease? It's going to increase. Why is going to increase the atomic radius as you're going down? Because the level of energy, they are increasing. So you have to circle the one that has largest. So let me erase that over here. Because between boron and aluminum is the one that has the biggest one. Sodium and aluminum. Okay, sodium and aluminum, they are in the same period. Over here you have a same period. Okay, you know that when you move from left to right in the same period, the atomic radius is gonna decrease. Why is gonna decrease? Because the nucleus is growing faster than the level of energy, because the level of energy, they stay the same. So the nucleus is gonna attract the cloud towards the center. So over here, okay, sodium is the one that has the biggest one. Sulfur and oxygen. Sulfur and oxygen, same group. Oxygen is in period 2, sulfur is in period 3. So sulfur is the one with the biggest one. And then we have oxygen and fluorine. Oxygen and fluorine, same period. Oxygen has the biggest one because as you move from left to right, it's gonna decrease. Okay, same group, bromine and chloride. Okay, the biggest one is bromine. Oh my goodness, this is not fair. Bromine, because bromine has one more level of energy than chlorine. Magnesium and calcium. Magnesium and calcium, the biggest one is calcium because it's in period 4, while magnesium is in period 3, so calcium has one more level of energy. Now, the greatest ionization energy, you're going to put that over here. In a period, ionization energy increases. Let me erase this. Maria, okay, let me stop. Okay, so in a period, okay, let me put that over here in a period. Ionization energy is going to increase. It's going to increase. Yeah, I was explaining why. If the atomic radius is getting smaller, the nucleus has full control over the electrons that are on the last level of energy. So it's going to be impossible to like get those electrons in the last level of energy because the nucleus is holding tight on them. So in a period, ionization energy is going to increase. In a group, the ionization energy is going to decrease because it's very difficult just to control the ones that are in the last level of energy due to the fact that as you go down a group, the level of energy are increasing. Ionization energy in a group is going to decrease. Okay, so first you have lithium and beryllium. Lithium and beryllium, same period. So across the period is going to increase. The one with the greatest one is going to be beryllium. Calcium and barium. Calcium and barium, same group. Okay, so the one that has the greatest, so calcium, barium. Calcium is in period 4, barium is in period 6, meaning that calcium is the one with the highest ionization energy. Sodium and potassium. Sodium and potassium, sodium has more control of the electron because it has less level of energy. Phosphorus and argon, ionization energy. Okay, ionization to steal them. And in this case, you have a noble gas over here. And you know that noble gases, they are very stable because the last level of energy is going to fulfill the Opter rule. I don't know if you memorize the definition of Opter rule. Ability, is the ability to reach chemical stability by completing the last level of energy with a electron. So between phosphorus and argon, so you're moving across a period. So this one is going to have the highest ionization energy because it's going to be very difficult. Noble gases, they are non-reactive because they are completed. they have a lot of money. They have $8 million in the bank account, meaning that they have the A electrons. So it's very difficult to steal the electrons from them. Chlorine and silicon. Chlorine and silicon. What is silicon? I don't see that over there. Okay, they are in the same period. Same period. So the farther that you go on the period, the higher the ionization energy is going to be. Okay? They were told to complete, yeah, I'm recording now. They were told to complete the homework formation classwork / homework formation of ion. And it's due today, December 8th at midnight. I don't know if they're doing that, but they were told to do that. Okay, they have to answer the question using complete sentence. It's here on this video. So I have evidence. Okay, let me continue checking this homework. Define electronegativity is so simple. In other words, electronegativity it is. Okay, let me start with uppercase. Okay. It is the ability to remove electrons, or steal electrons from other elements. Okay. Ms. Ramos, one more time, you're talking about this. Okay, you know that the tendency of the metal is just to lose electrons. And the tendency of the non-metals is just to accept them. Okay? Accept electrons. Do you think that the non-metals, they're going to be able to steal electrons? Okay. And what are you saying that, Ms. Ramos? Because now, you have to find between the two that you have over there, the one with the greatest electronegativity. In a period, electronegativity is going to increase. Why? Because you are moving from the metals, which are the ones that are losing, to the non-metals that are the ones that are stealing. They are stealing from everyone. And when they cannot steal, they share. Okay? And then when you go down a group, electronegativity decreases. Because since the level of energy are increasing, it's impossible for that element just to steal another electron from another element. Okay, so you have calcium and you have gallium. Your first step when you're solving a problem like this is just to look at the periodic table. Ms. Ramos, what's going to happen when you're not giving us a periodic table and you're giving us, instead of the name of the element, you're giving us the atomic number? Okay. Do you know how to write the electron configuration of elements? I was teaching you that. Do you know how to find the position in the periodic table of the elements by looking at the electron configuration? I was teaching you that. Okay, so let's say that I'm not giving you a periodic table, and I'm giving you the atomic number of an X element and a Y element. Can you find which one has like a greatest electronegativity without looking at the periodic table? Yes, but you have to write the electron configuration. Electron configuration, then you look at the position on the periodic table, and then you analyze the trend. But in this case, they're giving you the name of the element. You have calcium and gallium. Calcium and gallium, they're in the same period. Same period. Calcium is in group 2 and gallium is in group 13. So you are moving across the period. What happened across the period? The electronegativity is going to increase. So gallium is the one that has the highest electronegativity. Bromide and, I don't know the name, astatine. Okay, bromide. They're in the same period. Bromide is the one with the highest electronegativity because AS is in group 15, while bromide is in group 17. Lithium and oxygen, again, same period. Listen, when you have a metal and a non-metal, the non-metal always is going to have the greatest electronegativity. Barium and a strontium, you are talking about the same group. You have two metals in there, but you're going down. So strontium is the one with the highest electronegativity because as you're going down a group, electronegativity is going to decrease. Chlorine and sulfur. Chlorine, the one with the highest electronegativity. And then you have oxygen and sulfur. You're going down a group. Okay, oxygen is the one with the highest electronegativity. When a chlorine atoms form an ion, its radius increases. But when a sodium, and I love this, I'm going to explain this question step by step. Okay, you have over here chlorine. Atomic number equal to 17. This is the atomic number. Atomic number. Okay. Electron configuration 1s2, 2s2, 2, P6. A ver, I have 10. 3s2. I have 12. 3p5. See that? Okay. Last level of energy, you have only 7 electrons. Those are the valence electrons. It's gonna be easy for chlorine to let go 7 or just to accept 1. Of course, that accepting 1 will take less energy. That's what is happening in real life. But now you have 17 protons. They are positive. Plus, if chlorine is accepting 1, you don't have 17 electrons anymore. Now you're going to have 17 electrons if they are negative, okay? Because you are adding 1 in this one. So instead of 5, you're going to have 6 in there. When you do the math, plus 17 plus negative 18, this is what we call a negative ion or an anion in chemistry. Now, if chlorine is accepting 1 electron, what is going to happen to the ionic radius? Of course, it's going to increase. So the ionic radius for chlorine is going to increase. Why? Because it's accepting 1 electron. It's going to increase because it's accepting 1 electron. It is accepting 1 electron. That's chlorine. Now sodium is a metal. What is the tendency of the metal? Okay, sodium, atomic number. Atomic number is equal to 11. So 1s2, 2s2, 2p6, 3s1. Okay, last level of energy. Okay, in order to reach chemical stability, all elements, they need A electrons in the last level of energy. That's the octet rule. Okay, no, it's gonna be easy for sodium to let go 1 or to accept 7. But of course, the letting go 1 is more efficient. And you know that nature does, okay, work using the less amount of energy. She is so smart and clever. That's why sodium is losing 1 electron instead of gaining 7. But now sodium has, okay, 11 protons. But after losing this 1, okay, it's not going to disappear. Now you know that that electron is going to the chlorine. See? After losing 1 electron, sodium doesn't have the last level of energy. So what's going to happen to the ionic radius? It's going to decrease. And now sodium has, instead of 11 electrons, 10 electrons. Do the math. Plus 11 plus negative 10. And now sodium has reached stability, chemical stability, by losing 1 electron. And this is a positive ion. Why a positive ion? Because it's not neutral anymore. Now it has a charge equal to +1, and we call the positive ions cations. Ions. Okay? Pero when sodium was losing that last level of energy, what was happening to the ionic radius? The ionic radius for sodium was decreasing. And that's the explanation to all the problem. Was decreasing. And this is so simple. Between lithium, silicon, and sulfur. Sulfur is a metal. Silicon, a metalloid. Which one is the metal? Lithium. A smallest ionization energy. In this case, you have to look at the periodic table. Nitrogen, phosphorus, astatine. You are down a group. This is imperial, a ver, 2. This is imperial 3. This is imperial 4. The smallest one, this is the one. Largest atomic mass. And now you have to look at the periodic table, but that's so simple because this is in group 1. This is in group 2. Scandium is in group 3. Okay, atomic mass, if you are increasing or you are moving to all the way from the left to the right, the atomic mass is increasing. Largest atomic mass, scandium. Sulfur, chlorine, and argon, same period. Sulfur, chlorine, and argon, member of the halogen family. No. You know that the member of the halogens are the ones that are located in group 17. What is the only one located in group 17? Argon is a noble gas because it's in group 18. And sulfur is in group 16, which is the oxygen family. Aluminum, silicon, and phosphorus. Aluminum, silicon, and phosphorus. You are moving across. You are moving across a period. Electroaffinity is electronegativity. Okay? So silicon and phosphorus, this is the one that has the highest one. Largest atomic radius, you have gallium, aluminum, and then you have silicon. Gallium, you have aluminum, gallium and aluminum, they are in the same group. And then you have silicon, okay, which is in another group. Between, okay, this one, you're going to eliminate that because it's in group 14, okay? And as you move from left to right, it's going to decrease. Now you're going to analyze gallium and aluminum because they are in the same group. As you're going down, it's going to increase because you have one more level of energy. O sea que the biggest one is gallium. Let me erase the other two because I don't want you to get confused. Biggest one, gallium. Vanadium, whatever and whatever. Now, barium and whatever is the other one that I don't remember the name. Transition metal. Those are transition metals. Vanadium. Okay, they are in the same group. They are in group 5. Okay? Period 4, period 5, and period 6. Largest atomic number as you're going down, the atomic number is increasing. So it's, okay, vanadium, Ta, atomic number. And member of noble gases. Oh, my madre, it's so simple. It's this one. Because the one that is located in group 18 is xenon. Let me see what is the other. Oh, no, see, we have more. Okay. 4 level of energy. When you have that over here, you're going to look for the one that is located in period 4. Silicon is in period 1, 2, 3. Silicon is in period 3. Germanium. A ver, germanium. What is germanium? 1, 2, 3. This is in period 4. SN, okay, I don't remember the name, is in period 1, 2, 3, 4, period 5. So the one that has 4 level of energy is germanium, that is in period 4. Lithium, beryllium, and boron. They are in the same period, period 2, member of the alkali metal. But the alkali metals, you know that are the metals that are located in group 1. So it's lithium over here. 6 valence electrons. Okay? 6. In order to have 6 valence electrons, the element has to be located in group 16. So I'm going to look over here. I know that bromine is in group 17. Selenium is this one. 16. The other one is in group 15. Okay, so is this one over here. Non-metal. Lithium is a metal. Sodium is a metal. Both of them, they are located in group 1. So alkaline metal. Hydrogen is the only one in that group that is not a metal. Member of transition metals. Transition metals are the metals that are located in group 3 all the way through group 12. Okay? A ver, I have mercury that is in group 12. These two, this in group 13, and lead is in group 14. Okay, so the member of the transition metal is mercury, because the other two, they are located in representative group. Group 13 and group 14. Just keep that in mind. Group 1 and 2 and 13 all the way through 18 elements are representative. Electron distribution, I love this part. SP. If the ending is SP, that means that the element is going to be located in groups 13 all the way through 18. So you have to add the two numbers that you have on top, the superscript. 2 plus 1 is 3, and then you have to put a 1 in front. So electron distribution is telling me that that element is located in group 13. Sodium is in group 1. Magnesium is in group 2. Aluminum is the one that is in group 13. Metalloid, lead, bismuth, and polonium. Okay, that part, okay, I have to look at the periodic table because I don't know that for sure. Metalloids are the ones that are in green in your periodic table. I know that lead is not the one. Polonium tampoco. So the only one that is left over there is bismuth. Okay? That's the metalloids. Okay, boron, carbon, and nitrogen. All of them, bueno. Boron is a metalloid. Sometimes it's gonna behave as a metal. Sometimes it's gonna behave as a non-metal. Now, gas at room temperature. I know that carbon is not. It's not a gas at room temperature. The boron, I doubt it. But nitrogen, I know that is a gas because right now we have been exposed to 1 atmosphere of pressure. We are breathing air. If the air contains nitrogen, oxygen, and traces of sulfur dioxide, carbon dioxide, and other oxides in there. So nitrogen is the one that is a gas at STP, standard temperature and pressure, which is 25 degrees Celsius and 1 atmosphere. Electron distribution, SD. You know, look at the ending. That's a transition element. Transition element. You're going to find the group by adding the two numbers. 2 plus 2 is 4. So I'm looking for an element that is located in group 4. I know that calcium is located in group 2. And scandium is going to be located in what group? Scandium is in group 3. So the only one is I am titanium. Okay, titanium. Okay, is the one that is in group 4. With all the information that you have in this video, I think that you're going to study for your test, okay? Without no problems. See, no excuse. Now you have a video with all the homework explained. Is you're responsible. You're going to say that slowly. It is you're responsible. For my class, you don't have to be at school. See that? Because videos are going to be posted explaining the topic. I'm taking my time and spending my money, making sure that you have the instruction even though you're not in a school. Okay? So now I'm passing the ball to you. Good luck on the test.